Assalamualaikum warahmatullahi wabarakatuh. We are from group 4.0 GPA, and today we are going to present on our group project, which is self-service kiosk system. Before we go into the slide, let me introduce you to our group members. So firstly, we have TENGKU KHAIRUL IKRAM, Muzammel Anwar, which is myself, and also AMMAR. We will start with the introduction first. So what exactly is this system is? So first of all, our system, which is self-service grocery kiosk system, is an interactive, decentralized retail point of sale or POS application, was designed to streamline the checkout process for customers. Our system also allows customers to independently scan a food products or their drink, and they can review and edit their shopping basket and conclude their purchase to generate a transaction receipt. So what is the purpose of our project is we want to provide an intuitive, fast, and also a reliable self-checkout experience for the customer. And it also designed to reduce wait times and minimize the need for the cashier assistance. And now we move on to our first system requirements, which is stakeholders. So in these stakeholders, we have our primary actor, which is we can see here a customer. So the customer is the everyday shoppers who physically interact with the kiosk to scan items and process payment. So the role of the customer is to physically engage with the kiosk terminal, and because they have zero technical training, we designed the UI to be intuitive so that a user can walk up, scan an item, and pay in seconds. So next one we have store attendants. So the staff overseeing the self-service area who handle manual interventions. This includes like age verification for restricted items or fixing basic hardware jams. So in our architecture, we ensure that the system can pause their state and alert an attendant without losing the customer's current card data. And next one, we have a store management, which is their role is the operational executive that manage the grocery store's business back end. So their goal is business accuracy, and they rely on the kiosk to successfully relay every transaction back to the store central database. And for the last stakeholder, we have technical maintenance, or we call as IT support. So they are responsible for deploying, updating, and maintaining the software. So later we will explain about our design pattern, which we using a PAC pattern. Now we will move on to our functional requirement. So for functional requirement, we have around seven. So first of all, we have item input and scanning. So this retrieve and display the corresponding item details, which is the name and the unit price of the product from the local abstraction layer when the customer is scan the barcode. So next one, we have card display and real-time updates. So this will instantly updates the visible subtotal whenever an item is added, modified, or removed. And next one, we have cart modifications. So this will enables the customer to completely remove a selected item from their shopping cart. And also we have checkout initiation and calculation. This will automatically calculate the final total, which is all the products that they have buy, and the system will calculate the sum of all items and plus if there are any taxes. For the next one, we have a payment processing simulation. So the system will update the internal transaction state to completed once the customer has made a payment, whether they are using a QR or their debit card. And next one, a receipt generation. So this will display a summarized list of purchased items, quantity, individual prices of the product, total tax, and the final paid amount that they will get on the receipt. And for the last one, we have a session reset functionality. And after all the payment has been made by the customer, it will automatically resets to the idle state, which is the home page, after a receipt has been displayed for a set duration. Next, for the non-functional requirements, first of all, we have a performance quality, which is we want our system to be fast. So the UI must register scans and update the card display within zero point 0.5 seconds to prevent the frustration of the customer. And next one, we want our system to be usability. So the interface must be highly intuitive, requiring zero training for customers that never used a kiosk self-service before. And for the next one, we want the system to be maintainability. So the system must be strictly modular using the presentation abstraction control architecture. For example, when they update the receipt layout, it doesn't affect the scanner. And for the last one, we want our system to be reliability. So the top level controller must catching errors from bottom level agents, and they will display a graceful prompt rather than it crash the whole app. And for the last non-functional requirement, we want our system to have a security quality. So every transaction calculations must be securely processed without exposing their raw logic to the UI. For now, we will look on our use case diagram. So in this diagram, we have about three actors, which are customer, store attendant or cashier, and also store system, or also called as database. So the task of this use case diagram, we have scan item, manage card, checkout, cancel transaction, verify age, process payment, and also generate receipt. So if we look at the process payment use case, we draw an include relationship pointing to the generate receipt. So we map it this way because a receipt absolutely cannot exist without a successfully completed payment, and it is a mandatory dependency. So if they have not made a payment yet, they will get a receipt. And next, we will look at the verified age. So we drew this as an extend relationship from scan item because age verification is optional and it will only triggers under a specific condition like scanning a restricted item. Now let's move on to the first test case, which is scan item. For precondition, the kiosk is active and in an idle state, which means that the database is online. For the post condition, the scan item is successfully added to the user's active session and the UI subtitle of the customer's total payment is also updated. For the basic pass, firstly user scans the item's barcode using the kiosk scanner, and then system will queries the database for the item ID. The system retrieves the item name and price. The system will add the item to the card abstraction layer. And lastly, the system will display the newly added item and updates the total price on the screen. For the alternate pass, which we can see at the step 3, the system, if the system flags the item as age restricted, for example, the customer want to buy a specific medications, it will pause and prompts the store attendant to come and verifies their ID, and they will enter an override code, and the system will return to step 4 which means in the basic pass. And then for exceptional pass, if the item is not found, which is in step 2, the system queries doesn't found in the database, the system will display an error message which is item not recognized. Please seek a system, and it will returns to the step 1. For the next test case, we have a managed card. For precondition, the user has already scanned at least one item, and the card interface is actively displaying items. For the post condition, the card accurately reflects the user's modification, such as updated quantities or remove items. And for the basic pass, system will display the list of scanned items with options to modify. So the user can select a specific item in the cart. The user can increase their quantity, or also they can also decrease their quantity. And next, the system will recalculate the subtotal based on the new quantities. And lastly, the system will update the screen to show the new subtotal and updated item list. And for the alternate pass, if the user decrease the quantity, it will return back to the step 4, which is the system will calculate again the new subtotal of the prices. And same for A2, which is if the user remove the item, it will calculate back and return to the step 4. For the last test case of our project, which is a process payment and checkout. So for precondition, the card must have at least contains one item. So if they don't have any item, they can't click the checkout button. So for the post condition, when all the transaction is completed, the payment is recorded and a receipt is also generated. For the pass, system will calculate the final total amount, including any taxes. The system will display the final payment screen and prompts the user to confirm payment. And the user will click on the confirm payment to simulate the transaction. The system will send the transaction request to the simulated store database, and the system will receive a successful payment confirmation. And the system will display on the kiosk that said payment is successful. And the system will trigger the receipt agent to generate and display the final receipt. For the alternate pass, which is cancel at checkout. So if in step 2, when the user decides to cancel, and after they click the cancel transaction, the system will clear all the card that have been added by the customer, and it will return to the home page or idle scan screen. And for exceptional pass, for a payment decline, so in step 5, so the simulated database rejects the payment. For example, if they have an insufficient funds or network error, the system will reject it and display a payment decline. And it will say, please try again. And it will return to the step 2, which is it will display the final payment screen. For now, I will explain on the flow of our flowchart. So firstly, the user will scan a barcode of their product. So if the barcode is found in the database, it will add the item to the cart, and the subtotal will be updated. And if the barcode doesn't exist in the database, it will show an error and it will return back to the scan barcode. And for the next one, the system will check if the item is age restricted. If it is, it will call an attendance to verify the customer's ID. And if the item is not age restricted, it will go to the scan another item. If the user wants to buy another item or they want to add any more products, it will go back to the scan barcode. If they don't want, it will proceed with the user selects a checkout button. And after that, they are required to press a cancel transaction or not. If they press that one, it will clear the card and the system will go back to the idle homepage. And if not, it will calculate the tax and also the subtotal of the items, and it will prompt and process payment. And after that, when user has made an payment and the system already received it, it will generate a receipt. And if the system doesn't receive any payment from the user, such as if the payment is declined or an insufficient fund, it will show that it will display a payment fail and returns back to the process payment and ask the user to pay again, and it will continue until end. For activity diagram, we have three lanes, which is customer, kiosk system, and also store attendant. So firstly, we start with the customer lane. So the customer will scan the item, and next one, it will go to the kiosk system lane, which is it will validate the item in the database. So is it age restricted? So if it yes, it will go to the lane of store attendant, and they will verify their ID and override it. And next, it will move to the update card and subtotal in the kiosk system. And then it move back to the customer lane, which is they will select a checkout button. And then if they after they press that, it will move on back to the kiosk system, which is it will calculate the total and tax. And after that, it will prompt a payment, and it will pass on to the customer lane back to confirm their payment. And then it will move back to the kiosk system, which is it will process the transaction. And after the process transaction have been made, the system will generate a receipt for the customer.
So the next part is the detailed design of our system. So the first component is a barcode scanner agent. So it follows the PAC structure and work as an independent input system. Its main job is to read barcode data from the scanner and identify the product. So first it has three parts. First, the abstraction stores product data using the simple hash map like a mini product database. Second, the presentation layer shows message like product found or not found without knowing how data is stored. And the third one is the control layer, which connects everything by checking the barcode, getting the product, and sending the result to main system. So the important idea is separation, which how the scanner works on its own. Uh, so we can change the database or UI later without affecting other parts like the card or payment system. Next, shopping cart agent. So shopping cart agent keeps track of the user's item during the shopping session so that the data doesn't disappear after each scan. The abstraction layer stores item in an array list and also handles calculations like price, total, and 6% tax. So this makes sure all the prices are calculated correctly in one place. And then the control layer manages updates. If an item already exists in the cart, you just increase the quantity instead of adding a duplicate. And if it's a new item, it adds as a new entry. It also sends updates to the screen and can clear the cart when needed. And then the third one is the payment and receipt agent. So this component handles payment and receipt generation. It manages the final step of the shopping process. The system simulates a payment gateway using the payment control class. It checks whether the payment is successful or not. If the payment is successful, the system generates a receipt showing all items, tax, and total amount. The key feature is error handling. If the payment fails, the system simply returns to the cart without deleting any items. So this ensures that the user doesn't lose their shopping data. Once everything is successful, the system resets and gets ready for the next customer.
Now, I will explain the PSC architecture and use in our self-service grocery kiosk system. This diagram illustrates how the system is organized using the presentation abstraction control architectural pattern. So, PSC divides the system into multiple independent agents where each agent contains its own presentation, abstraction, and control components. At the top of the hierarchy, we have the main kiosk controller agent. This is the top level agent responsible for managing the overall system lifecycle, routing requests, and coordinating communication between all lower level agents. It acts as the central controller of the entire kiosk system. Below it is the transaction session agent. This agent manages the active checkout session, store transaction metadata, and controls the workflow of the transaction process. It serves as an intermediary between the top level controller and the specialized agents. At the bottom level, we have three specialized agents. First is the barcode scanner agent, which handles barcode input, validation, and product retrieval. Second is the shopping cart agent, which manages cart contents, item quantities, and subtotal calculation. Third is the payment and receipt agent, which handles payment processing, transaction status update, and receipt generation. One of the key advantages of this architecture is that each agent operates independently. This means that changes or updates to one agent can be made without affecting the functionality of other agents. As a result, the system becomes more modular, maintainable, and scalable. Besides supporting the functional requirements, the PSC architecture also helps the system achieve several important non-functional requirements. For performance, the system uses local state caching within the abstraction layers. This allows shopping cart calculation, such as subtotal and tax computation, to be performed instantly without repeatedly accessing an external database. For usability, PSC separates the presentation layer from the business logic. This allows the user to interface to remain simple, consistent, and easy to understand. For maintainability, each agent is fully encapsulated. For example, if the grocery store decides to upgrade the barcode scanner or connect to a different product database, only the barcode scanner agents need to be modified. The shopping cart and payment agent can continue operating without changes. Then for reliability, PSC provides isolated error handling. If a barcode cannot be recognized, the scanner agent can display an error message without causing the entire kiosk system to fail. This improves fault tolerance and system stability. And the last one, for security, all transaction information is stored only within the active session. Once a transaction is completed or cancelled, the system clears all temporary card and payment data, ensuring that customer information is not retained for the next session. Overall, PSC was selected because it offers high modularity, easier maintenance, better fault tolerance, and improved the scalability. These characteristics make it highly suitable for a self-service grocery kiosk environment where reliability and responsiveness are critical. So now, I will explain the implementation of the prototype and how each PSC component works together to fulfill the system requirements. First, this section contains the core data models used by the system. The product class stores information about each grocery item, including its barcode, product name, and price. The cart item class represents a product that has been added into the shopping cart. It also stores the quantity purchased by the customer. And then the get total method calculates the total cost for a specific item by multiplying the product price with its quantity. These classes form the foundation of the system because all other PSC agents use the data during the checkout process. Then, the barcode scanner agent This screenshot shows the implementation of the barcode scanning agent using the PSC architecture. The first component is the abstraction layer, which contains a simple product database storing predefined grocery items. Next is the presentation layer, which handles all message displayed to the customer, such as item found or item not found notifications. Finally, the control layer processes the barcode entered by the customer. It communicates with the abstraction layer to retrieve the product information and then sends the result to the presentation layer. This agent fulfills functional requirement FRO1, which is item scanning and product retrieval. And then this section represents the shopping cart agent. The abstraction layer stores all scanned items inside the shopping cart and performs calculations such as subtotal, tax, and final total amount. The get subtotal function calculates the total value of all items currently in the cart. Then the get tax function calculates a 6% tax, while the get final total function calculates the overall payable amount. The presentation layer is responsible for displaying the current shopping cart and subtotal to the customer in real time. This directly supports functional requirement FRO2, which requires real-time cart updates. And then this shows the control layer of the shopping cart agent. The add item method adds a new product into the cart. If the same product already exists, the system increases the quantity instead of creating a duplicate item. The display cart method updates the user interface by displaying all cart items and the current subtotal. The clear cart method removes all items from the cart when a transaction is cancelled or completed. This component ensures that the cart remains synchronized with customer actions throughout the checkout process. This section implements the payment and receipt agent. The presentation layer generates the digital receipt and displays transaction details such as purchase item, subtotal, tax amount, and final payment amount. The control layer manages payment confirmation through the process payment function. When the customer confirms payment, the system processes the transaction and generates a receipt using the generate receipt method. These fulfill the functional requirements FRO5 and FRO6, which are payment processing and receipt generation. This screenshot shows the main kiosk controller, which acts as the top-level PSC agent. The main kiosk controller coordinates communication between the barcode scanner agent, shopping cart agent, and payment agent. The start functions display the main menu and controls the overall system flow. The checkout function validates the cart and initiates payment processing when the customer chooses to proceed. Finally, the main class serves as the program entry point and launches the kiosk system. This controller ensures that all PSC agents work together as a complete self-service grocery kiosk. So here are the output. This demonstrates the final output of the prototype. So the customer scans grocery item by entering product barcodes. The system successfully retrieves product information and adds the product into the shopping cart. So the cart subtotal is updated automatically after each scan. When checkout is selected, the system calculates the final amount, including tax, and requests payment confirmation. So after payment is approved, a digital receipt is generated showing all the purchased item, subtotal, tax, and total payment. So this output proof that the prototype successfully fulfills the major functional requirement of the self-service grocery kiosk system, including the item scanning, cart management, payment processing, receipt generation, and the last one, session reset. So that's all.